Welcome to Big Data Essentials, an introductory overview that sets the stage for how raw data becomes strategic insight. In this lecture, we will explore core concepts, architectures, analytics methods, and governance considerations, aiming to connect practical pipeline steps with business outcomes so you can see where data initiatives create real value. This slide compares structured, semi-structured, and unstructured data and highlights the role of metadata in making sense of diverse sources. From relational tables to JSON logs and multimedia files, integrating these types adds complexity to ingestion and processing pipelines, and the diagram shows how metadata helps provide context, while mixed formats can complicate downstream analytics. Here we examine the main drivers pushing organizations toward big data: competitive pressure, digitization, and affordable cloud infrastructure, all creating an expanding data exhaust. The funnel graphic shows how proliferating devices and platforms increase the digital footprint, and the strategic payoff ranges from new revenue models and cost reduction to faster innovation cycles driven by real-time insights. This slide lays out the analytics value chain from descriptive reporting through diagnostic, predictive, and prescriptive stages, showing how insights translate into decisions. The flow from data ingestion to analytics processing and decision execution improves KPIs at each step, enabling better reporting, root cause analysis, forecasting, and ultimately optimized actions that drive measurable business outcomes. The Big Data Lifecycle graphic walks through identification, acquisition, filtering, extraction, validation, cleansing, aggregation, analysis, visualization, and utilization, with governance checkpoints along the way. Common bottlenecks like schema drift and privacy compliance are highlighted, reminding us that a reliable lifecycle needs both technical controls and operational policies to turn raw inputs into actionable, trustable insights. This slide compares data systems and trade-offs, contrasting OLTP and OLAP workloads, data warehouses versus lakes, and how CAP theorem influences distributed system design. It also illustrates scalability approaches, like columnar storage and distributed file systems, and describes processing zones for cold batch versus near real-time hot paths, helping you choose architectures that match latency, consistency, and analytics goals. Statistical inference at scale covers distributions, parameter estimation, and hypothesis testing, tailored for large datasets. The diagram emphasizes point estimates, confidence intervals, and the need to control false positives with techniques like Bonferroni adjustments, while also calling out robust estimators to handle outliers, so models stay reliable when training complex algorithms. Dimensionality reduction techniques such as PCA, multidimensional scaling, and diffusion maps are presented as tools to preserve variance, pairwise distances, or manifold structure while reducing features. The Eigenvalue Spectra Guide helps select reduced dimensions, and the slide underscores the practical benefits: lower computation, noise removal, and clearer patterns for clustering or visualization downstream. This slide introduces core supervised learning models, linear and logistic regression, SVMs, and decision trees, and outlines the model training process of data splitting, training and evaluation, plus risks like overfitting and the role of feature engineering and regularization. The final emphasis connects models to business impact, such as personalization, engines, and fraud detection systems that drive measurable value. Advanced analytics shows clustering approaches for segmentation, k-means, spectral and hierarchical, and how those segments enable targeted strategies. On the right, reinforcement learning basics map states, actions, rewards, and policies, contrasting model-free and model-based methods and highlighting real-time adaptation for dynamic environments where continuous learning improves decisions. Big data ethics and governance focuses on provenance, privacy, consent, bias, mitigation, and accountability, explaining how tracking data origin and applying anonymization techniques support compliance. The slide stresses obtaining explicit consent, reducing algorithmic bias, and establishing governance bodies and audits so organizations protect reputation and reduce legal risk. while unlocking trustworthy data-driven capabilities. The final slide on key trends points to real-time streaming and edge analytics, growing automation and AutoML, plus the importance of explainable AI and a continuous learning mindset. Together, these trends, amplified by evolving hardware and algorithms, accelerate time to insight and emphasize business value as the ultimate metric for prioritizing future investments.